Here is a modeling question to do with geometry. Uh, the volume of a cylinder, and we're going to think of a soda can as a cylinder, and then the surface area. So we're going to use these formulas to help, and we're going to need a calculator today. So the Fresha Drink Company is marketing a new soft drink. The drink will be sold in a Funsize, I have a smaller version, which holds 200 centimeters cubed of volume. Here are two suggestions for the radius of the can. So the guy says, hey, mine is 2 centimeters radius, and the girl says, 5 centimeter radius. So each of these holds 200 centimeters. Find the heights of these two cans. So if the radius is 2 centimeters, how do I find the height using the volume formula? So the volume is pi r squared h. I know the volume is 200. The radius in the first case is 2, and I'm solving for the height. So to get h by itself, use your calculator, and you can go 200 divided by 4 pi, and then write it as a decimal so you have a good sense of it. So for the first one, what would the height be? So 200 divided by 4 pi. So then the second one has a radius of 5 centimeters. So the one with 2 centimeter radius has a height of about 16 centimeters. The second one, I'm going to do the same calculation, but instead of 2, I'm going to plug in 5. Obviously, it's going to give a smaller height. So 5 squared is 25. So it's 25 pi. So 200 divided by 25 pi. Now my printer's going off just because it feels like it. So 200 divided by 25 pi is about 2.5 or so for a height. So one gives you a height of 16 centimeters, and the other one 2.5 centimeters. So I don't know how good you're on a metric. You should be comfortable with both. Think of 2.5 centimeters as like 2.2 centimeters. I think is an inch high. 16 centimeters, it's a lot taller. So are the dimensions of the can suitable to be able to for this situation as a soda can? So what would be a good answer? Are they both suitable for the height of a can? And you would like to think, I would like to think, that a radius of 2 centimeters gives a reasonable height of 16 centimeters. A radius of 5 centimeters gives an unreasonable height of 2.5 centimeters because it would be difficult to hold. It's so short for a soda can. To be fat, and it'd be wide, but it would be not very tall. So it'd be difficult to hold to do things. Explain why you think that would be the case. It is too wide and too short. The second one. All right, number 2. Number 2, it says find the surface area of the two cans. So to find the surface area, we have a formula for surface area, which is 2 pi r squared, that's the top circle and the bottom circle, the bases, and then 2 pi r h is like the circumference times the height that gives you the belly of the cylinder. So if it was, the first one was what, 2 centimeters for a radius? If that's the case, the surface area then would be 2 pi, 2 for the radius, 2 pi, 2 for the radius, and we just said the height was, now I'm going to use a whole number, what, about 16, right, I said? So I'm going to use that. So if you do that correctly, what is the approximate surface area? Use your calculator. The answer matters like what you round to and stuff, but The answer is about 225 centimeters squared. Now, the reason we say squared here for the surface area is now it's area. Now, what happens if the radius was 5 centimeters? What would the surface area be? So for the second one, again, it would be 2 pi r squared plus 2 pi. The radius is 5. And we just said the height was, what, 2.5? So put that in your calculator. And what would be the approximate surface area of the second one? So it's about 236, 39, 38, something in there, approximately. So the second one is unreasonable because it's wide and too short for a can. It also uses more material to make. Something to think about. So you can see what the surface area is for each one. Now, part 3, the last part of the task. It says, in order to keep costs low, the Fresha Drink Company wants to sell the drink in cans that use the smallest amount of aluminum. Find the approximate radius and height of a can that holds 200 centimeters cubed and use the smallest amount of aluminum. Show clearly how you figured out the size of the can, and then mark your dimensions correct to the nearest 0.5 centimeters. So we already have, and we're going to just do a table of values here. So we're going to use radius, height, volume. We know. What's the name? Surface area. That's what that says. That's the surface area of each one. Now we already know for 2. So if it's 2, the height was, let me go back here, about 16. So radius of 2 centimeters, height of 16 centimeters gives me about a 225 centimeters squared of surface area in terms of aluminum. I also did 5, but we need to do 2.5. We need to do 3, so increments of 3.5. So let's see if I can create a nice little chart here that would be easy to use and then use your calculator. Let's do a fun little chart. So I just want to remind you to find the height once you know the volume is you're going to take the volume, which is 200, and you remember what we did each time? We just divided by pi r squared. So that's what I'm going to do each time. So it's 200 divided by pi r squared. So in this case, it's 200 divided by pi 2.5. I'm just going to follow that like a little formula each time. So for the height, I get about 2.2. And then for the surface area, remember it's 2 pi r squared plus 2 pi r times the height, which we just said is 10.2. So that gives me, using a calculator, about 199.5 or about 200 centimeters squared. Let's look at the next one, 3. So I'm just going to follow that pattern. 200 divided by pi, 3 squared, that's going to give me the height. So 200 divided by 9 pi. So that's about 7 for the height. And so to find the surface area, I'm going to plug in 3 for the radius and then 7 for the height. And so for 3, that gives me about 190 centimeters squared. So that uses less aluminum. 3.5, so 200 divided by pi, 3.5 squared. You can use a calculator for that. So that height for that one is about 5